We know the orbit of the Earth around the Sun, and we know the orbit of the Moon around the Earth. But what is more difficult to understand is the way the Moon orbits around the Sun. Most books show this orbit something like this, with the Sun in the center and the Moon having a loopy pattern around it. This may seem to make sense right off the bat, but honestly it's not even close to being correct. There are two issues with it. The first one is scale. Okay, so now we're outside and we are going to try to put the scale issue even in greater detail. So Seth, if I took the Earth and shrunk it down to the size of that softball that you're holding in your hand there, and I took the Moon and I shrunk it down to the size of the golf ball that Sydney's holding in her hand there, how far apart do you think that they would be?
I think 2 feet.
Seth says 2 feet. How about you, Sydney? What do you think?
I think 5.
5 feet, huh? Well, okay, let's see if we can figure out how far apart they really are. We've got here on the road, not the safest place to be, but probably the best for what we're trying to do. Right now, Sydney's standing about 2 feet away from Seth. That's where Seth said the Moon would be from the Earth. And so now Sydney needs to move a little bit further away, so move to your right, or your left there, Sid. A little more. A little more. Okay, that's good. Nope, that's too far. That's good, right about there. That's about what Sydney said it would be, about that distance right there. Actually, it's 12 feet. So Sydney needs to scoot down. That would take 7 big steps. That's good, right about there. That's actually how far away the Moon is from the Earth. Now, how far do you think the Sun will be away, Seth? How far? What? The light post or the tree or what?
I say down to the mailbox.
Seth says to the mailbox. How about you, Pete?
Down to the garden on the other side of the driveway.
Down to the garden. Okay, well, let's see, all right? This is the light leaving the Sun. We're actually going faster than the speed of light. The light normally takes about 9 minutes to get from the Sun to the Earth, and we'll do this trip in about a minute. Coming up here is the garden that Sydney said would be how far the Sun is away, and there's the mailbox that Seth said. And if you can see, we're arriving at the Moon right about now, and now we're arriving at the Earth. The other issue that comes up when looking at this type of orbit is speed, and how fast the Earth and the Moon travel through space. Maybe the best way to show this is through the eyes of a race car fan. Watch this short video clip and see what you think. Notice that while there's an obvious circular motion by the trailing car around the car in the middle lane, there is never actually any backward movement of the car going around. There's always forward momentum, never any backward movement. And so the looping pattern that's shown in the books cannot happen. In fact, if we were to put paint on the tires of the cars, one path would show a circular pattern with no changes in direction, while the other path would look as if it was weaving in and out of traffic. This is exactly the path that the Moon and the Earth take around the Sun. Instead, we get an orbit that looks like this. Although it's quite exaggerated, it's far more accurate than the alternative.
Fly me to the moon, let me swing among those stars, let me see what spring is like on Jupiter and Mars. In other words,